Okay. So I guess we're leading into the final discussion section. And there was a question for the previous speaker in chat, and maybe we could address that quickly and then start to discuss more open-ended stuff. So this was a question from Fabiano Silva to Professor Richards, and he was wondering if you were building globule models for the calculations that you were running.
All right, can you hear me?
Yes.
Oh, you can. Okay, so the pods are working. So no. I mean, so we're just using the standard kind of methodology where we pick all atoms within a certain distance, 12 angstroms of the ligands, and to create some kind of active site model. And then within MOPAC itself, it's I've forgotten the option, but atoms that are greater than a certain distance away. So we've actually picked a 12 angstrom sphere and we picked a 10 angstrom cutoff. Atoms that are between 10 and 12 angstroms don't move. They're kind of included, their effects are included in the calculation. But everybody else is allowed to geometry optimize within that 10 angstrom sphere. So it's a fairly standard algorithm that's implemented in MOPAC. That we use. We didn't do anything special, and then we put everything in a implicit solvation model so that we don't see any weird electrostatics. The electrostatics aren't overcompensated, so if you had a positive and a negative, they don't get too close together like they would in a gas phase simulation. So it's a very standard active site model kind of way of working. So nothing special.
The keyword that you're after is opt.
Yes, that's the one.
So in my code, I do something similar. I when you do a selection of a ligand, I say any protein within 3.5 angstrom. That's a default thing. You can change it, but I include the entire peptide, so the whole amino acid is included.
Yeah.
And then my code will automatically terminate those terminal chains, the A, the C, and the N, to be neutral by default. You can do it as Witter ions if you really want to.
So the other thing I would say is that the model needs to be big enough to accommodate all of the hydrogen bonds that are important in the active site. So, you know, if you can take the ligand protein hydrogen bonds, but it turns out there are second shell hydrogen bonds between protein residues that will also modulate what goes on in the system. And it's not so important in the example I showed, but we've been looking at arginine kinase. There you have a hydrogen bonding network that goes out for at least 12 angstroms. And so we've been using much bigger models to make sure that we include all of the relevant hydrogen bonds. And
That's fantastic. I didn't know.
To your phosphate point, phosphates are a particular problem. You've got to get the hydrogen bonds to the phosphates, but you've also got to get the hydrogen bonds to the residues that interact with the phosphates. So that's why arginine kinase was such a problem, because we're using ATP and transferring a phosphate onto an arginine residue. So you've got all of these charged interactions that you really have to get right in the model. So, so the size of the model you pick is very dependent on the, if you like, the second sphere, if you like, of hydrogen bonding interactions that you need to include to get the kind of electrostatic and the right in the actual model. That's been our experience.
Oh, that's really cool. Thanks, Nigel.
All right, yeah, structure preparation is very challenging, and trying to like decide where to make these sort of truncations, and there can be, I guess, like shell effects where you might add more and actually makes things worse potentially temporarily. Yeah, those are very scary to me.
Well, we got quite a lot of advice from Mr. MOPAC. It turned out, much to his chagrin, you know, that even with a time difference of what is it, 7 hours, He could still be contacted. So I was just going to make the point, not only, the other thing that we try and do with our models for the people who are interested is we try and keep them charge neutral if we can. We don't like to have models with net charge on them one way or the other. Okay, that's the other rule that we try and follow.
Right.
If the model is too small, then it's unrealistic. If it gets bigger, then the issue of multiple minima becomes more important. So you got to find the sweet spot.
Yeah, there's problems in both asymptotics, so you gotta balance your.
This is not in the textbooks.
So this is kind of an open discussion, so I'm happy to have people direct this in any direction. But something came to mind from the end of Nigel Moriarty's talk that I wanted to bring up. I thought it would be a very good topic to start with, and we can shift to other things. But as MOPAC is used, people encounter isolated problems that perhaps are limitations in the current models or parameterizations. And there's always been kind of, I guess, an ad hoc system of those problems are often reported back to Jimmy Stewart. And on the old website, there's even a place that he's kept a partial record of faults that have been reported. So there's somewhat of a system of public accounting of that to some degree. And it would be really nice in the future, I think, if that was, I don't know, automated, but just like if that process is integrated more explicitly into the open source version of MOPAC, or just the general effort around it, because it is important for semi-empirical modeling. Like it's supposed to be adapted to the distribution of popular usage. And so when faults are encountered in that distribution, there needs to be some feedback back to the development so that the new models can be informed by those problems and know that those are problems of particular interest to be resolved in the future. So I don't really have any answers to this, but I'm wondering if anyone else has any thoughts on that. Like if there's various places to report software problems because GitHub is for software development. And in principle, those tools could be co-opted to also report model problems. And you could think of them as a problem associated with the software since it's happening within a piece of software, even though it's more a problem with the underlying science and models. But that might help track things in a more systematic way. And then when it comes time to develop new models, people can refer to those list of problematic cases to try to, emphasize those or add a high weight to those in the development of new models and not overlook them, because it's easy to produce a new model that looks good on some test set that is not representing progress on what people actually want these models to make progress on. So they need to be as adaptive and responsive as possible, I think. But I'm not clear how to proceed with that exactly. Like I'm certainly going to try to have some mechanism to do this, but I don't know if anyone has any thoughts on maybe a natural or optimal mechanism to accommodate these kinds of interactions with users. Kind of an open-ended question, so yeah, I don't know if there's any nice answers to that.
I think it's a good idea to collect these issues for sure, but yeah, the question is what should be considered a real problem to address, what is result of some approximation that can be fixed. But having some place for that would be useful if people used it. Certainly not every issue like this can be fixed or will be fixed. I'm not sure if enough information can be gathered this way because what we do is like running calculations on large data sets and looking what comes out. And now there is so much data that this allows us to identify the problems quite efficiently. And I still don't know if we can fix them. We will see later. Yeah, but having some tracker for this kind of things, it will be definitely nice to try, and we'll see what we can get from that.
Okay. I mean, there is kind of, this is something I've noticed recently, not with model errors, but just support in general. Like when you're running a support channel, you hear complaints, but you don't know what fraction of people are complaining. Like it's hard to capture like the success rate. Like I don't know if the 1 or 2 people complaining every now and then are representing 1% of users, 0.1% of users, all of users. Like that's one of the nice things about commercial software is like you can count your customers and you can count. There's dollars in the bank associated with each customer. The open source model of software development doesn't really have nice mechanisms in place to monitor usage, to know if problems are outliers or regular occurrences. So that's something that's a bit frustrating, and I don't, because then I kind of worry, if something is very isolated or there, because whenever you hear one problem, you can imagine that there are maybe multiple people having the same problem, and only one of those people was willing to speak up about it. So you worry about the silent pain going on associated with every user report of a problem.
Yeah, our experience in Phoenix is that we're trying to figure out how many people are suffering in silence. We made it very easy, and we've always encouraged every time we give a presentation to a group of users, because we have user meetings twice a year. We put up the email address for we're now using Jira bug tracker, and it's both for bugs and for development issues. And we make sure that everybody knows, and we're in a slightly different situation is that we can count how many people have deposited a model to the PDB and if they've used Phoenix or not. And so we know that more people are depositing structures using Phoenix than any other software at the moment. So we're happy about that. But when we get a bug report from a user, we try to respond quickly. And then if we see the same bug 2 or 3 times, we really try and solve that one very quickly. So yeah, we don't know how many people are suffering in silence, but we know that people are trying very hard to get their models deposited. So we sort of have a slightly different amount of motivation.
Okay, so there's a software specific mechanism of monitoring usage effectively.
Yeah, if they're depositing a structure, that means they got it to work.
Yeah. Okay. Yeah, and I guess the footprint in the literature, seeing successful uses of MOPAC that lead to publications, is something of that sort for any scientific software. But yeah,
Jonathan, I was just going to reply based on reports we get back about WebMO. All software has bugs, right? And so the question then is, how do you prioritize responses to them? And at the same level, the comment also applies to feature requests. Everybody wants, their feature implemented. And we also don't really have a mechanism that actively can ascertain how frequently this bug is occurring. But so we have to make the decision ourselves quite often. Where do we put our own effort? And one set of words that comes up fairly frequently is this a corner case, or is this something sort of more general? And I mean, I'm just saying the obvious, but if it is a case that just sort of arises in sort of one very, very specific instance, we kind of keep track of it, but that's not our first priority. But if it's something that either is general and affects, a wide number of what we perceive to be uses, that ups its priority scale quite a bit. That's probably totally obvious, but we kind of talked that through a little bit, like, is this a corner case or not? I just say that, and then I'm probably just saying the obvious.
And I think that's, Joe?
This is Joe Leonard here jumping in. I just wanted to point out, having done tremendous amounts of commercial software, there's no way to distinguish working from not used. Because you see a bug report indicates they used it and found a problem. If it works or sits on their shelf, nothing is reported. So
Yeah, I guess that's a good point.
our biggest problem, which you may share with open source, is do you even know it's being used? Or you, as you said, as the guy said, all software have bugs, but they may not matter and it may not be used, and it's frustrating.
Yeah, I mean, I think commercial software development has, to some degree, has an answer to that now, in that like a lot of software is moving to use-based charging, and so software is probably less likely to sit on a shelf if you're paying a recurring cost for it. So that may align profit with usage.
Yeah, but remember, as Richard pointed out for Mo, there is only one product, and it has all applications. So if you're doing macromolecular modeling in a force field, you may or may not know that there's small molecule tools.
Yeah, I guess more monolithic software has
Yeah,
those
I mean,
challenges.
it's the users prefer not seeing unbundled software that costs them more in many cases. So it's a difficult balance.
Yeah, I mean, it'd be nice if, I mean, since this is a common problem in open source software development, it'd be nice if there was like some way of, some common tools provided to all projects to help with usage and some kind of usage monitoring. But yeah, there's not a great answer to
We
that.
tried that with Tripus back in the 90s. They used, I think, a standard commercial licensing mechanism, and it had the ability to echo back usage of tokens to the mothership. Customers thought that was a staggeringly evil thing.
Okay, yeah, I guess there's privacy issues that people would have. And that's why, I mean, the degree to which this does, like, so there are various opt-in systems in the open source world. Like you can star projects, and when you clone projects, that's noted as well. Like, so there are ways to track popularity, but popularity is different from usage. Like there's a weighting on enthusiasm of users and things like that. That's not necessarily standard overall groups of users. So these are all steps in the right direction.
Yep. Jonathan,
Yep.
There's another effect. You can train the user community, and if you respond quickly to problems and at least acknowledge them or fix them, preferably, people will report them. If they report something once or twice and get no response, they just will stop. And at some level, you don't really care how many people are having a problem if you fix it. And so you want to you want to encourage the community to report things. And the principal way of doing that is being responsive. Even if you're saying, well, I can't fix this, at least they know you're listening.
I see. Okay. Yeah. Well, trying my best with that these days. So I'm very responsive to the support emails and GitHub issues.
I've noticed, and you don't seem to have so many issues coming up that you can't be.
Yeah. So some projects are pretty overwhelmed. Like some I actually submitted a GitHub issue to PySCF last year and fixed it myself. But that gave me a glimpse into just the scope and the frequency of. They have thousands of issues that have piled up unresolved, and it's at the point where like they're not realistically going to handle all of the issues, and maybe they have some way of just retiring them and not worrying about them in the future. I don't even know, but yeah, like there's certainly not a traffic jam like that with MOPAC yet, but it hasn't been in the open source space long enough to develop that kind of problem, and maybe it will in the future. Yeah. Are there any other topics of discussion? So we're at the point where this is kind of the end of the official meeting, and I'm happy to stick around and discuss if people are interested. But this has been a bit of a long meeting. You know, I tried to scope it so that'd be about a half-day meeting. That meant just packing everything in and not really having much in the way of breaks and things. So at this point, I think people are probably starting to get tired. I am a bit as well. But yeah. So this is the end of the regular meeting, and if people do want to stick around a little bit more, I will stick around until pretty much everyone is left. So yeah.
I just wanted to thank Jimmy again for creating MOPAC, and thank you again for keeping it going.
Yeah,
it's very, very helpful to the science, and I hope it's going to be very helpful to the customer base, yours and ours.
And yeah, and I'm just thrilled that Rebecca has resurrected Indo. It was a great thing and it fell out of use, but it really worked. I used to use it a lot in the 90s. It's really, really good.
Yeah, I don't know if there's any other accessibility points for Indo right now. MOPAC may be the easiest way to get access to Indo at the moment. Like I haven't really scoured other codes for that as a feature.
There is some Indo in Orca. It's only CIS, and it is a slightly different parameter set. There's a really old version in Gaussian that I have no idea where their parameter set came from, but I think it's not very good.
Yeah, but the code base you built on top of that, that wasn't publicly available, right? That's something you had to request through private channels.
I did request it through private channels. I think there have been versions that have been at least semi-publicly released at various points.
Okay, well, I think it was one of the many programs distributed on the QCPE back in the day, but that's portfolio of programs has basically been lost to time at this point. So unless people have made them available through other channels, you know, no one has a catalog of that anymore. We actually mostly tried to get access to that at some point, but QCP shut down more or less in the early 2000s, and there wasn't enough of an archival effort early enough to keep a record of that, unfortunately. And there were also legal issues. The licenses under which they distributed software didn't make it easy for them to just keep copies in perpetuity. So.
Rebecca, without holding you to a full answer, is your feeling that your parameters that are now in MOPAC are sort of the original Zindo, the parameters that were in the program Zindo?
So I don't think they were the original parameters that Zerner published. Exactly where they came from, I'm not 100% sure. I wasn't able to track that down. I tried and was not successful.
Mm-hmm. Okay, thank you.
But I mean, similar to the just external parameter file for the other methods, that does work for the Indo parameters as well.
So, yeah, there was no definitive Zerner collection. It would vary. Oxygen would have several values, parameters that would change depending on what happened. It was towards the end, it was kind of interesting, yeah. But it would be good if there's now a standard set that's to build on. That's very good. I'm very excited to learn about this.
Well, yeah, one of MOPAC's successes in the history of semi-empirical modeling was releasing clearly defined models. Like, there was a lot of semi-empirical modeling activity, but people kind of were hesitant to really take a snapshot and say, okay, this is this model, here is its parameters, and then kind of having a jump to developing a new model that would be very clearly distinct from that. So that's been a practical success of MOPAC.
And I think, Nigel, that's a good point. Some of the functionality, like Indo in MOPAC, QM, MMQM, they're there, they're documented, but not many people know that they're available. And it should be publicity about these essentially orphaned functionalities.
Yeah.
Sorry, Rebecca, it's not orphan, but you know what I mean. what you presented was very good. And I thought, why don't people use that?
So I would second that. I think that TDDFT, which doesn't really work, it's a kludged up thing. People use that all the time, and people have forgotten that the Indo methods were really very, very good. They gave extremely good agreement with experiment, and you know, Mike did a whole bunch on porphyrins that still state of the art in many respects, and somehow the community just forgot about it. Maybe because it was hard to access the software. I don't know what the reason was.
Yeah. Well, on the new website, I'm planning to add more tutorial content that might help delineate common use cases, and that could be used to highlight features that aren't used enough right now. And you know, like in Rebecca's case, I might invite her to try to put together some of those tutorials if, you know, the people responsible for those features are still responsive and accessible. Because I don't want to have to write them all myself.
And short YouTube lessons in how to do certain things.
Yeah, that's a possibility. If we commit to tutorial content, we may try to attach them to associated YouTube videos. We'll see how that goes. We need to come up with kind of a standard and compelling way to show command line type activity. I mean, and maybe it could be in partnership with some GUI, but then we have to make decisions. Which GUI are we partnering with? And not all GUIs are going to expose all features. So that kind of shapes usage a bit. So yeah, there's still some thoughtfulness to be done about that. But it is certainly something that we're planning to do. All right. I don't know. At this point, I think maybe we should just wrap it up and call it a successful meeting. So this has been recorded, and I will try to cut this up into the individual talks, and eventually, hopefully in the next week or so, post that onto YouTube and maybe advertise that. Yeah, and there may be an exit survey. I still need to put that together that I might send out to people, but that would be very short, maybe in the next couple of days, in case anyone had any closing thoughts. But yep, all right. So thanks everyone for showing up. I think we can all call it a day.
Yeah, thanks for
Thank
organizing
you, Jonathan,
this.
for organizing this.
Yep.
Thanks.